everyone, in this video we will be solving system of inequalities by graphing. This is the first part. I will put the link of the second part in the description box below. Before we jump into this first example right here, let's have a review on graphing inequalities in two variables. Okay, so we remember that if we have a greater than or equal to or less than or equal to, we're going to use the solid graph. Now, if we have a greater or less than, we're going to use the broken graph. Okay, so we go over the first example. Okay, so the first thing that we're going to do here is to determine the slope and the y-intercept for the first line. So the first line right here, our slope m is 1/2 and our b is 3. We remember that m represents the slope and this will tell us where to go, up, down, left, or right. So let's graph this inequality right here. So we start with 3 as the y-intercept. That would be on the y-axis. That's 3. To get to the next dot, we remember that our m represents, the top represents up or down, then the bottom represents left or right. Since these are all positive, that means we are supposed to go up and right, since both of them again are positive. So we go ahead and say that from the y-intercept, I go up 1, and then I go to the right 2, 1 and 2. So this is the second dot. So what are we going to do now is we are going to connect these dots together, and then we are supposed to use a broken line. So the reason why it's broken, because there is no bar underneath. So this is a broken line. So I will draw the broken line. Okay, after we did the broken line, we are supposed to determine which side do we shade. Is it above the B or below the y-intercept? There's a trick to do this. Remember that if y is isolated by itself, on the left side, locate the vertex, and from the vertex, shade the side above the vertex if it's greater than or equal to. Shade the side below the vertex if it's less than or equal to. In this problem right here, it says that it is greater than, so we shade above the vertex. So we're shading above this point right here. So all of these are actually solution to this inequality. Okay, now we're ready to move on to the second equation. So the second equation is y is less than -3/4x minus 2. So we're going to determine the m and the b. So the m that we have right here is -3/4, and then the b is -2. So what are we going to do is we plot the b first, which is on -2. That's on the y-intercept. So this is our b. And then our m, this is -3/4. Remember, if it's negative on top, we go down. So that means we go down 3. And then we go, this is positive. So that is, we go to the right 4. So that means from the y-intercept, which is -2, I go down 3. So 1, 2, 3. Then I go to the right 4. 1, 2, 3, 4. So then this is the second dot. And then from here, we are going to connect the dots together. Please remember that this one right here has a bar underneath. So we're supposed to use a solid line. So we're going to use a solid line for this. So I'm going to draw the line right here. Okay, now we determine which side do we shade. Is it above the y-intercept or below the y-intercept? Remember the trick. If y is isolated by itself on the left side, locate the vertex, and from the vertex, shade above the vertex if it's greater than or less than. If it's greater than or equal to, shade the one that is below the vertex if it's less than or equal to. Since this is less than, we're gonna shade below. So we are shading anywhere below this line. So below this dot. So we are shading all of the ones that are below. Okay, the solution to this inequality is the intersection between this red and blue graph. This means that our solution actually sits around here. So this is our solution on this side. So this one is only for the red. So this side is only for the red, this one is only for the blue. They are actually intersecting here. So that means both the red and the blue are actually located here. So that means our solution is on this portion. Now let's look at this problem right here. We determine are the points below solution or not a solution to the system of inequalities. So it should work to both of them, not only for the red, not only for the blue, but it should be to both of them. So we have here negative 7, 2. So that would be negative 7, 1, 2, 3, 4, 5, 6, 7, and then 2. So it's right here. Since this dot is located on the portion where the red and the blue color overlap, it's this portion right here. So that means this is a solution. Now we have 0, 0. 0, 0 is right here. It is not on the intersection between the red and the blue, or it's not on the overlapping portion of the red and the blue graph. So that means this is not a solution. At this time, I would encourage you to pause this video and try this problem out on your own. And when you're done, unpause it and check your answer. Okay, so we go over the problem here. So first, we are going to graph the first one here. So in this problem, we are given the m is gonna be negative 3 over 2, and then the b is positive 1. So then from here, we go ahead and graph the b first, which is on positive 1. So please remember that if we are given the slope represents this. Since this is a negative 3, that means we go down. So we're going down 3. And then since this is a positive 2, so we go to the right 2. So we're going to write right there. So then from here, I go down 3. 1, 2, 3. Then I go to the right 2. 1, 2. So this is the second dot. So then we're ready to connect these dots together. Now please remember that this one has no bar underneath, so we're going to use a broken line. So that's gonna be a broken line right there. So I will connect these two dots together with a broken line. Okay, so what are we going to do now is we shade the portion that is a solution to this inequality. Remember, the trick to this is if y is isolated by itself on the left side, locate the vertex or the y-intercept and shade above the vertex if it's greater than or equal to. Shade below the vertex if it's less than or equal to. Since this is greater than, we're going to shade above the vertex. So we're going to shade above this point. So all right here would be solution. Now we are graphing the second equation right here. Since this is not in y equals mx plus b, we're supposed to change this to y equals mx plus b form. So we're going to add 6 to both sides plus 6. So then we can cross this out. We're left with 2y minus 3x is greater than or equal to 6. So then we want the y by itself. So we're going to add 3x to both sides plus 3x. So then we are left with 2y is greater than or equal to 3x plus 6. Now others are going to think that, oh, that should be 9x because we have a 6 plus 3x. That is not the way how to do it. This 6 and 3x are not like terms. You're not supposed to add them together. So you're supposed to separate them from each other. So that's y equal 2y equals 3x plus 6. Since we want y by itself here, so we're dividing 2 to both sides. Divide this by 2. Divide this by 2. So then we are left with y is greater than or equal to 3 over 2x plus 3. So we can use this equation in order to graph this equation right here. These two are equivalent. So then from here, we can go ahead and say that our slope is 3 over 2. And then our b is 3, which means that we start from 3. So I go to positive 3. That's 1, 2, 3. So it's going to be right here. And then since this is 3 over 2, this means that we go up 3 and we go to the right 2. So I go up 3, 1, 2, 3. I go to the right 2, 1, 2. So this is the second dot, and I'm going to connect these dots together. And since this one has a bar underneath, we're going to use a solid line. So I'm gonna draw a solid line that connects these two dots together. Okay, now I'm going to determine which side do I shade. Is it above the y-intercept or below the y-intercept? Now remember the trick. If the y is isolated by itself, on the left side, locate the vertex, and from the vertex, shade the side above the vertex if it's greater than or equal to. Shade the side below the vertex if it's less than or equal to. Since this is greater than, we are shading above the vertex. So above the vertex means here, so we are shading all of the ones that are above the vertex. This means that the intersection between this red inequality and then this blue inequality right here is actually here. So this portion right here is a solution to both of these inequalities. Did you get the same answers as this? Good. Perfect. If you find this video helpful, hit like and subscribe for more math videos. See ya!